Okay, so now we have the hardest problems to factor. And that's when I not only have a leading coefficient that is not 1, but it's also not a prime number. So we have a lot of guessing and checking to do for the factors that are going to work, to multiply to be the number on the end, and add up to be the number in the middle when they get multiplied by the factors, this composite number at the beginning. So I'll start, I'm going to write the factors out that multiply to make 6. Well, that's 1 times 6, and it's also 2 times 3. So I don't know which pair that could be that can go inside of the binomial. I just know that the binomials, when I make them, that I'm going to have k times k to make k squared, but I don't know what their coefficients are. They could be a 1 and a 6 or a 2 and a 3. Now, I got to go write out the list of all the numbers that multiply together to make 45. Well, 45. Now, I have all pluses in the middle, so I'm only going to worry about the positive factors. So 45 can be formed by the product of 1 times 45. Now, I'm going to leave myself some room because I have to check to see if if they get multiplied by 1 and 6, or 6 and 1, or 2 and 3, or 3 and 2. So there's one set. Now, what else multiplies together to be 45? Well, 4 plus 5 is 9. 9 is divisible by 3, so 3's got to go into it. So 3 and 15. And we also have 5 can go into it, 5 times 9. So those are my pairs of factors that will multiply together to make positive 45. Now, through the process of foiling or distributing out our binomial product, one of those blue numbers are going to get multiplied by my green numbers, which represents the factors of my leading coefficient, and it's trial and error. So everything has positive here, so I don't have to worry about any negative signs. So let's experiment and see. 1 times 1 plus 6 times 45, and let's add them together, and we'll see if that makes positive 37. Well, 1 times 1 is 1. 45 times 6, 270. So 271, nowhere close. So no way that's going to be it. Well, what if I changed the order around and said, all right, well, maybe it's still 1 and 45. But instead of multiplying the 1 by 1, let's times it by 6, and the 45 by 1, and let's reevaluate. Well, if I did that, I would get 51. So that didn't work. Well, that doesn't mean I go and I scrap and say, all right, let's go to 3 and 15 next. I also need to try multiplying by 2 and 3. So I'm going to multiply the 1 by 2, the 45 by 3, and then I'm going to add them together and see what I get. Well, 1 times 2 is 2. 45 times 3 is 135. That gives me 137. Nowhere close to my 37. Well, let's try to multiply them in a little different order before we eliminate it. So 1 and 45 still. Multiply the 1 by 3, the 45 by 2, and we'll add it together. We do that, 45 times 2 is 90, plus 3 is 93. So we've completely eliminated the possibilities of having 1 and 45. So now we go to 3 and 15, and we do the process all over again. So start with 3 times 1, 15 times 6, and we'll add, see if it makes our number in the middle. Well, 6 times 15 is 90, plus 3 makes 93. That's not my 37. Let's try the other order. So 3 and 15 multiply to 3 by 6 and the 15 by 1, and we'll add together. That gives me 18 plus 15, 33. So I was closer, but wasn't there. Now, we got to try to see if multiplying by 2 and 3 will work. So I'll keep my same factors of 3 and 15. And we're going to see if we multiply one of the numbers by 2 and the other numbers by 3, if that'll give me my sum I'm looking for. 2 times 3 is 6. 3 times 15 is 45. Add them together. I lost my train of thought. 51. Nope, not it. Let's change the order. So 3 and 15, I'm going to multiply the 3 this time by 3, the 15 this time by 2, and we're going to add and see if we can get it. Well, 15 times 2 is 30, 3 times 3 is 9, add them together, 39. It's not 37. So I know now I have to have a 5 and a 9. I just got to figure out, well, what do they got to get multiplied by? So we're going to keep the process going. So 5 times 1 and 9 times 6. That's the first set, the 1 and the 6 to try. And we'll see what that adds to be. 9 times 6 is 54, plus 5 is 59, not 37. Well, I still have other combinations to try. So 5 and 9. Let's try to multiply the 5 by 6 and the 9 by 1 this time, and we'll add them together. 6 times 5 is 30, plus the product of 1 and 9, I got 39. That's not 37. Well, we have one other arrangement. To multiply the 5 and the 9 by 2 and 3. Two times 5 is 10. 9 times 3 is 27. 27 plus 10 make 37. So there is my pairs. Now remember, I try to color coordinate this. The green numbers are the coefficients of k's. So I have to have a 2k and a 3k. Now the blue numbers are the constants that go inside the binomial as well. So the 2k has to multiply to a 5, where the only way that could happen is the plus 5 has to go in the other set of parentheses, because I can't multiply a number that's in the same parentheses because they're technically adding. And the 3, which goes with 3k, has to multiply to a positive 9. So that means I need to have plus 9 over here with that 2k, and here is my binomial. These are difficult to do. That's why they're the hardest ones. All right, let's go to this one here. So we'll do number 3. All right, well, similar scenario here. All right, I'd love to be able just to set up and go, but I can't because the coefficient of x squared is not a 1, and not only that, 8 is a composite number, meaning that I have multiple factors that can create it. 1 times 8 and 2 times 4. So we got to do this whole thing over again. Now we go and we look at and say, all right, well, the last number is positive 14, but I also see a negative sign inside of here. So that means I also have to account for numbers being positive and negative in my list. Well, positive 14 can be created by taking -1 and multiplying it by -14. Now I'm going to leave some room so that way I can do all my testing. Another option is positive 1 times positive 14. I also could have negative 2 and negative 7. And I have positive 2 and positive 7. Now, if I'm trying to eliminate my workload here, I know I have to add up to be a negative number here in the middle. So what I can do is, I know there's no way possible that I could have both positive numbers. Because, yes, two positive numbers multiply together to be a positive, but they'll never add up to create a negative, especially when the numbers that I'm looking at that multiply together to make positive 8 are all positives here. I'm not having negative numbers in front of there. I'm going to treat those with positive coefficients. So I really only have two sets of numbers to test here. Negative 1, negative 14, negative 2, and negative 7. So one of those is going to get multiplied by a positive 1, and one of those is going to get multiplied by a positive 8. And then I want to see if they'll add together to make negative 23. Well, when I go and I do 1 times negative 1, it gives me negative 1, plus 8 times negative 14. There's no way that's going to make negative 23. It's just going to be, the number's going to be too large. In fact, it's going to be negative 113. So I almost didn't even need to try it, but I just did it for this video. Now, let's see if I switched what I multiplied by and say, all right, well, what if I multiply the negative 1 by 8 and the negative 14 by 1 and then re-added the numbers together? What does that give me? Well, negative 8 plus 14, or excuse me, negative 8 plus negative 14 gives me negative 22. Close, but daggone, that's not negative 23. So I got to look and see, before I give up on this pair, let's see about what happens with when I multiply by 2 and 4. Well, 2 times negative 1 is negative 2. 4 times negative 14. There's no way that's going to make negative 23. So there's no need for me to even really bother with that. But if you're writing it down, it's negative 58. We try to do it in a different order. And say, all right, well, let's multiply the negative 1 by 4 and the negative 14 by 2 and re-add. That would give me negative 4 plus negative 28, negative 32. So I have eliminated negative 1 and 14 as a possible option. So now we go to our next possible pair, which would be negative 2 and negative 7. So I'll start, see if 1 and 8 will work. Well, I'll have negative 2 and plus negative 7 plus 8. Because the signs are the same, there's no way that's going to make that negative 23. But I'd have negative 58. So I know that pair wasn't going to work. Let's try to multiply the numbers in a different order. So negative 2 and negative 7. Let's multiply that 2 by 8, that negative 7 by a 1, and add them. We'd have negative 16 plus negative 7. Negative 16 plus negative 7. That makes negative 23. I found my pair. Now, the green numbers, I didn't pre-make my binomial, or my binomials. The only thing I know is that the leading ones both have to have x's right now. The numbers that the coefficients of the x's are green. So I have to have an 8x and a 1x. Doesn't matter where I put it, but let's say I had 8 and 1 right here. The numbers that they're multiplying to are the other numbers that go in the binomial. So the 8 has to multiply to the -2, which means the -2 has to go in the opposite binomial. The 1x has to multiply to the -7, so that means the 1x has to be away from the -7. They got to be opposite of the binomials from each other. And so we have factored this problem. It's a lot of trial and error. It takes time.